you for joining our anniversary webinar. My name is Adia Kare, and I'm the marketing coordinator at Versity. So today I'm joined by our VP of Product, Meghan McClelland, and our Senior Principal Software Engineer, Ben McClelland. This week marks the 1-year anniversary of our Versity Gateway. And as most of you know, the Versity S3 Gateway is a high-performance S3 translation tool that allows various storage systems to seamlessly communicate with S3-based applications. On June 13th last year, we officially open sourced this project, and today we are thrilled to announce that it is generally available to be used in live environments. And so for today's agenda, Meghan will kick off this session by delving deeper into what inspired the gateway, and then following this, Ben will give a live product demo. Then we'll translate to the highlight of this event, a fireside chat with Ben, and capping off the session, Meghan will return to share the gateway's future by providing a glimpse into its roadmap. And so while we have time dedicated at the end for any of you to ask any specific questions, please feel free to use the Q&A or chat at any point in time. And so without further ado, I will give it over to Meghan to give us an overview of the gateway.
Okay, so we manage large data collections at the lowest possible cost. Our customers are using our software to create Glacier infrastructures for unstructured data preservation or managing huge data lake platforms, which are secondary storage, usually for HPC, sometimes for commercial or enterprise, but managing that data lake platform. And then also we're a highly differentiated replacement for existing legacy archive technologies like IBM HPSS, their Spectrum Archive, and also HPE's DMF. We have a global install base. We're managing 2 exabytes of data all around the world at over 95 sites. ScoutAM is our data management platform. Data comes in, it can come from pretty much anywhere and be pretty much anything. It comes into the ScoutAM system where it's grouped, optimized, and organized, and then managed on mass storage media. It can be any different combination of that mass storage media, which can include object, public or private, tape, or cloud. One of the ways that we manage to take in so many different kinds of data, so many different protocols, is that we have a piece of our product offering that is really a critical piece to enable S3 workloads, and that's the Versity Gateway. We can accept data, it's a put, it's a get, just like any regular S3 commands that you would use, and that data is translated to file data, which is then taken into the ScoutAM system. So for us and our product offering, it's very much an object to file translation tool. When we started building it, we had a solution that worked really well, and it was a popular version that was out in the community. Unfortunately, the company that had provided it, Minio, they decided to deprecate the gateway, and they also changed some of the licensing before that. It became a really unfriendly model that didn't work for a lot of people, including us. And so we knew that there was this gap in the community. There was a problem in our product offering that we needed to solve. We decided to develop a new version, a new gateway that we could use for this critical piece of our infrastructure for the incoming data. So we built the Versity Gateway. As Adia said, we started about a year ago. And the main things that we definitely wanted to have as product requirements for the gateway when we were building it that we had in mind, it needed to be scalable, it needed to have different modular backend support, and it needed to be open source. So in terms of being scalable, it's deployed in a cluster. Each instance is stateless. Performance scales linearly as you add more instances of the gateway. Ben will talk more about this in the fireside chat, but it's normal for us to see really high speed requirements with our customers between 20 and 50 gigabytes per second ingest and archive management. Those are very normal numbers for us to see in our customer base. So definitely one of our requirements that it has to be high performance and scalable. In terms of modular backend support, our use case is definitely S3 to file, but we had a lot of partners and even customers who were interested in, well, could it do S3 to something else? And yes, it absolutely can. And that's something that was built in from the beginning. One of the customers who was really interested in, can it do something else? Los Alamos National Laboratory. Ben will talk a little bit more about their use case further in the meeting. And then, of course, we wanted it to be open source. We wanted it to be a friendly license where it's usable for the community. We really want to build a community around the gateway and have people contribute to it and use it and deploy it so that it can be used by all. So with that, I'm going to hand it over to Ben, who has a demo of the gateway ready.
Okay, first I'm going to share my screen that has the GitHub project on here, just so that we know where to go to get the current releases and where we are currently tracking issues and other aspects of the gateway. So this is the main GitHub page. You can just get to it from github.com/versity/versity-gateway, Versity GW. The page has the code repo, but also a README at the bottom just for some introduction to what it's about. And then on the side, the releases here are the current tagged releases that we have. So you can click on releases, and the release assets have all the various binary releases as well as source code tarballs that you can download directly from GitHub here. So a lot of our users will be installing this on AMD 64 RPM architecture. And you can just download the RPM right here. We can copy the link for a little bit later here when we're going to do a demo. Another interesting thing that you might find that might be useful as you're getting started with the gateway is all of the documentation is available in the wiki. And so we have pretty extensive user documentation here, as well as some developer documentation for some of our partners that we're adding other backends and other contributions to the project. This has a breakdown of all of the features of the gateway and how to enable some of those features, some of the specific configuration examples and such. So this is a good place to go for reference of how to run the gateway. There are quite a few options that are available, and so there's a help menu when you run the gateway, but this will have a little bit of extra explanation for what are all the options available when running the gateway. So it's recommended to reference the wiki documentation here. So, okay, I'm gonna go hop over to my demo machine here. Share this screen. Okay. So here I have a little demo instance that I just started up here. I have installed the gateway, but if you want to install it from scratch, it is just a quick yum install command. This link came from the GitHub page for the releases, so you can just yum install directly that, or DNF install based on your distribution. The link that's directly from the GitHub page itself. We can just start the gateway by hand once it's installed. You can just run the Versity GW command. There's a default root account that is always specified through environment variable settings or command line options. So you specify what the root level access to the gateway is, and then which is going to be just test and test PW for the access key and secret key here. This works on any POSIX compatible file system, and then we give it the top level mount path that we want, the directory that you want to host via the gateway. And so you can just start that up, and that's as easy as it is to get it going. This is now running S3 server that's going to be translating S3 requests into that directory that's hosted at Mount GW. Another way doing this that is probably going to be more common in production is that we offer a systemd service when installing with the RPM. So I have a little demo configuration file here. This just specifies a few of the options similar to how I was specifying on the command line. And then we can just start this service. This is a templated service. And so you start this by doing Versity GW at, and then the name of the configuration file in the Versity GW.d directory. And so I have gateway1.conf. And so I'm going to start the Versity GW at gateway1.service. That starts up the service using that config file. We can see that the service is running. Similar output as what running it interactively is. I've also previously installed the AWS CLI. This is the official CLI supported from Amazon. I need to set a few environment variables to match what the running gateway is. And so I've set the access key and secret key to the ones that I've specified for my root level access in here. And then the default region is East 1, but you can specify other regions as well. And so now we can start interacting with this with the AWS CLI. We specified the endpoint URL. We specify the endpoint URL to match what our local instance is. And so this is just running on localhost port 7070. You can specify other ports as well for options, and you can listen on specific interfaces. By default, it's going to be listening on all interfaces. So we can make a bucket. We can make a little test bucket here. We can copy a file into our bucket, and we can ls that object directory that is created and see that we've uploaded our little data file here. And then looking directly in the backend, so this was specified, the backend arg is another file system that I have mounted, mount ScoutFS. S3 Gateway 1 is the root of the gateway in this example. And so the bucket is the top level directories within that root, the gateway root, and then all of the directories below the gateway root are mapped to buckets, and then the object names are split based on slash separators so that they're mapped into the file system namespace. And so uploading to the test bucket, and then the object name is dir slash data file, so it's going to create the directory dir, and it's going to upload the data file, and so we can look at that directly in the backend as that path and see the data file. And these are a direct mapping, and so we can check that the data does match the one that I uploaded with accessing it directly in the backend as well. And so uploading through the S3 interface gives us exactly the same file back in the file system. So this is what we're talking about with that common namespace access, is that you can upload and download files through the S3 API, but then you can also look at the file system directly and see those objects mapped in as files into the namespace as expected. So that's the demo for the simple start of this. Megan, do we want to?
We're going to hand it off to Anya
next.
for some questions for you for a fireside chat.
Yes, thank you so much, Ben, for that demo, and for Megan to highlight the key features of the gateway. And so before we dive into the chat, I wanted to briefly introduce Ben a bit more for those of you who may not know. He's been with Versity for over 9 years now and has been vital in developing our data management platform, ScoutAM, and now Versity Gateway. He's previously worked at Intel Corporation and the Los Alamos National Laboratory, and has immense experience in large-scale tape archiving and advanced data management solutions. So thank you so much, Ben, for coming to share your insights with us today. And I just wanted to start off this discussion by asking, what feedback have you received from the users of the Versity Gateway, and how has it influenced product development?
Yeah, so been very positive feedback so far. So we originally were developing this with Los Alamos National Lab because they had a need for accessing their computational object storage devices through an S3 interface because they had some client workloads that were already taking advantage of the S3 interface. And they had a need to offload some of the IO operations to these NVMe storage devices. And so they needed a translation layer as well in there. And so we had been talking with them and discussing that, well, we also need a translation layer to our storage that might have some special handling for our file system and archival workflows as well. And so started brainstorming ideas of how we could come up with an architecture design to support all of these requirements of various storage systems, and found out that there might be others as well out there that would like S3 access into their storage products, and they might have special handling within their storage system. So there's not necessarily a one size fits all here. We'd like to have something where we have S3 access on the front end that does all the protocol translation and then hands to the back end what that request is really trying to do in terms of what S3 action you're doing to the back end, and the back end system can implement however they want to handle that. And so we have some modules in there already that talk to POSIX file systems, talk to our ScoutFS file system. We have another S3 proxy in there that'll proxy to other S3 storage systems. But we envision that this could be expanded to other partner storage systems as well. And we have seen some interest in the community from both people in small or single person organizations just doing some hobby projects, all the way up to larger corporations that are interested in collaborating with us on how they can utilize the gateway as access to their storage platforms as well.
That makes sense. Yeah. So since you have a very wide usage of users that are using the gateway, what are some of the performance considerations you've taken into for the Versity Gateway, especially considering when using it at scale?
Yeah, so our file system is a clustered distributed file system. And so we definitely need scalability within a node as well as across a cluster of nodes. And so the original design we knew had to be a clustered capable design where we could scale out across multiple systems to get that overall throughput to the storage systems. And we didn't want to be constrained to any single system or single gateway instances. And so we've designed a stateless design for the gateway so that it really leverages the backend as the consistency model. And we don't have any communications between gateways. You can run, because of the stateless architecture of the gateway, and because the original design of Amazon S3 was to have very large scalability where you could have load balanced access to all of Amazon's S3 services out there. The S3 protocol itself allows for that load balancing distribution out there. So we've designed it in a similar way to take advantage of the S3 protocol design where we could load balance across multiple gateways as well. And so any S3 request can be handled by any gateway that's running across a cluster of nodes. There's no inner gateway communications. The communications are strictly to the backend storage system. And all of that consistency relies on, across gateways, relies on the backend storage to be offering consistent access to that. And so the gateway doesn't need to make any consistency promises or communications to enforce that. And so that allows us to be basically infinitely scalable up to the limitations of the backend. So you can deploy as many gateways on a single node. You can keep on deploying more nodes and more gateways, and will eventually saturate the backend storage system. But there's not going to be any scaling limitations within the gateway itself just because of the stateless, communicationless design.
Okay, I'm going to ask you a question from the Q&A. So it's a two-part question. The first one is that we do support, assuming we support HTTPS.
Yes, we do support HTTPS. So you just provide the SSL certs in the CLI options, and then that enables HTTPS mode. Some of the client access is a little tricky there because some of them you have to override certificate validation and stuff, which is why I usually don't demo with HTTPS, because it requires a few extra options to not. I always use self-signed certs when testing, and then you have to kind of override the certificate validations and stuff in the client. But yes, assuming you have valid certificates, you can enable HTTPS. Also, self-signed certs work as well, but you have to be able to handle that accordingly in all the various clients that have access to that. Did you want me to take the other part of the question too? I see a multi-tenancy.
Yes, multi-tenancy question.
Yes, and so we do have multi-tenancy access. This is pretty well documented in the wiki. So there's Megan has the page up now, but in the wiki documentation, go to multi-tenant IAM, and that'll give you the matrix. We do. Do you want me to share that, Megan? Okay, hang on one second. Let me get back to the. GitHub page. Okay, so here's our multi-tenant documentation page. And so we do have multiple classes of users here. And so the root user is what's specified at the CLI always, so that you never have to recover that account. You can just restart the gateway with whatever credentials you want there, and you always have those credential access. The rest of the users are stored within the IAM service, which is a modular service. So I'll talk about that in a second. And we have multiple roles. And so we have admin, user, and user plus. So admin is allowed access basically the same as root to everything. So all bucket access, all object access, and managing users. And so they can create and delete users. User role is only allowed access to their buckets. And so the basic user account isn't even allowed to create buckets. This is slightly different from AWS access, but it is more similar to what we've seen with other on-prem S3 services, where maybe storage admins want to control the buckets a little bit more. And so the admin would create buckets and then assign ownership of that bucket over to users. And then the user would only have access to the bucket that they've been assigned, specifically assigned access from admin. To close the gap of the AWS model, we also have a user plus role, where the user plus is also allowed to create their buckets, and they automatically get assigned to them. And so they have the ability to create buckets, but they only see and access their own buckets. They don't see the global view of buckets. We do have several different IAM services. So how do we store these accounts? This is the pluggable service. So we have this internal service where we're just storing all the accounts in a JSON file, and you give us the directory. This directory needs to be consistent across all gateways, such as like an NFS mount. This is mostly for testing purposes. It's not really necessarily meant for production use, because there's no encryption or anything. There's no protection on this. And so it's just a file that all the gateways would have access to. It should be okay to use as long as it's not in the object namespace. You wouldn't want to make that accessible in the object namespace. You'd want like a totally separate directory than what the gateway is hosting. We can do a similar thing with S3. So instead of a local file, we can create an object in an S3 bucket. This can be a gateway endpoint, or it can be like Amazon S3 or another on-prem S3 endpoint. This is mostly used for when we're doing S3 proxy mode. And so if you're proxying S3 requests through the gateway to another S3 storage system, then we would mainly use this for testing, so that we can have like another admin bucket with the user accounts in there. The first one that's really meant for production use is the HashiCorp Vault module that we've just recently added in there. This is great because this is actually specifically intended for housing secrets and encrypted access and stuff. So this is really the one that you would probably be interested in for production use, because this is taking all the security seriously here. And so this has all of the options that you need to enable the gateway to have access to the vault secrets. And then you would still manage users through the admin APIs in the gateway. And so you would create great gateway users and modify and delete users and stuff, and that would all be managed through Vault. And so as you're adding users, you actually specify all the credentials you want. As an admin, you would specify the user account and the credentials to create that account, and then you would give that account and credentials to the user of the system, and then they could start using that system. We also support LDAP, but the complexity of that is probably beyond the scope of what we want to talk about here. And then we have some cache settings for so that we can handle a lot of incoming requests to the system at a very high rate. And so instead of hammering the IAM services with each request incoming, we can have a local cache for each gateway so that it remembers an account for a little while that it asks the IAM service for, and then it can just reuse those credentials for a certain amount of time. So we have some timeout values and how long are those good for, and then how long after that it has to go and requery the service again. But this is just to try to ease the load on the IAM services. And then we have some examples for the user management here. And so this is, you can manage users. This is actually an API endpoint as well. And so you can do all the user management through the CLI with the Versity GW admin commands, or there's a little REST endpoint that you can use if you want to integrate that into other services as well. And this is just creating users with different user roles. You can specify the role as like admin or users here. And then there's listing where you can list the accounts and what the roles are. And then the other piece of this is if you do have just regular users, the admin has to be able to assign the bucket ownership to that user so that they can start accessing those, so that they have permissions to that. So this is not needed with User Plus, but with the basic user account, the admin can also create a bucket and then change the bucket owner over to the user. So yeah, this is the IAM multi-tenant capabilities of the gateway here.
Thanks, Ben. I think the next two user questions are really centered around the ScoutAM was using the Minio gateway. How do I know which gateway I'm running, and how do I change to use this new gateway, which has become generally available today? And what are the differences between this gateway and the Minio gateway?
Yeah, definitely. So you can tell which one you're running by the name. So the old one was called Scout GW, and the new one is called Versity GW. And so the naming, we have distinct namings for the one that was based on the MinIO source code. The one that had the MinIO integrations was pretty minimally added to from our support perspective. So we added the capability for the backend, but we weren't really supporting new features within the gateway itself. We were just supporting the backend access into ScoutFS. This is our project now, and so we have much more control over features. So if customers need new capabilities within the front end that are compatible with S3 or maybe incompatible with S3, we have that ability to take on that feature development because we have like full capabilities of modifying the Versity Gateway versus the kind of the MinIO stack that wasn't really under our control.
Is there a difference in framework or performance capabilities?
Yeah, definitely. Yeah, so MinIO has been around for quite some time, and so they were using a much older, kind of the original HTTP framework called Gorilla Mux, but that one has actually been deprecated, and I believe they had to fork the entire framework just so that they can continue supporting it. We're using the Go Fiber, which is a much more modern web framework, and it minimizes memory allocations, and it's really designed around the high performance capability. And so we've done some benchmarks, and we show very low overhead for gateways, for our gateway servicing requests. There's very low memory overhead, and using the gateway, we streamline a lot of the request handling, as well as like streaming the data directly to the backend, so that we're not having to cache a whole lot in memory or require large memory consumption there. I'm not certain how optimized that was in the MinIO one, so we're definitely more focused on the performance capabilities of this one with the Versity GW. And we'll be working with everybody to transition over. It's a very straightforward transition. A lot of the same commands are there, so a lot of the same features are in place. There's just maybe a couple of subtle differences, but it's not a difficult transition from the old gateway to the new gateway.
Perfect. So Matthew has a question about our Glacier mode for ScoutAM and other optimizations the gateway has. So would you expand on what ScoutAM optimizations we have and perhaps go into that a bit more?
Yeah, sure. I mean, I can do a Glacier demo. Megan, is now a good time for the demo? Okay, let me pull that up really quickly here and show. So this is, I'll do a Glacier demo here, and this is only available when combined with ScoutFS and ScoutAM. And so what we're going to look at here we go. So the way that ScoutAM works is that anything written to the file system gets an archive copy. And then once we have valid archive copies in the mass storage, so this would be tape or S3 or other archival mass storage systems, once those copies are made, the file is eligible for releasing the data. And so once we start filling up the file system, the system will automatically start releasing the data in the file system associated with the files that have data copies in the archive. And so the way we map that to S3 is that any online file is just using a standard storage class, and anything that's offline would be the Glacier storage class. And so we can see offline files as Glacier. And then the Glacier, when we have the Glacier mode enabled, it has a few special handling. Let me show this really quickly. And so I have an archive directory here with a data file, and the data file is offline right now. And so it has an archive copy and it's been released. And so this is the standard Glacier response from a get object. So we're trying to copy this data file from the gateway down to our local directory. And we're unable to read this because this is a Glacier object and you need to restore it before you actually read it. So this is how we map. This is what other applications would expect in terms of access to Glacier. And so we can issue the restore object API. So also note, right, we're still using just the standard off-the-shelf AWS command. So we issue the restore object command here. Let's see if I can capture this fast enough. And so when this is a ScoutAM command here, the samcli file ls-s detail gives us the metadata, the ScoutAM metadata for the file. We can see the archive copies here, but also it has the staging flag set. And so that restore object request came in and was translated into a batch stage request in ScoutAM. But now ScoutAM is handling that staging. Probably done now. So yep, now the file is online, no longer offline. So this is the offline flag and the staging. So that means it's still not available. So as long as it's offline, we would be getting the errors in the GET request. But now, if we do our GET request, now it's successful because the file is online again. So that's basically the Glacier workflows. The only missing component here for what a client access to Glacier would see is that in Glacier, you would get some sort of notification, usually using the AWS SNS notifications for when the file becomes online. ScoutAM offers stage notifications with Kafka and Nats and other message queues. And so you would plumb that into your local site if you do want those stage notifications to happen. ScoutAM can send the notification messages for when that file is online. All right,
Perfect.
that's the Glacier workflow.
So our next question from a participant is that Ben, you showed the S3 and file access. How do you manage permissions between S3 and POSIX file system?
Yeah, so this is a feature request that we haven't yet promised, but it looks like we might be able to support. So today, the gateway is expected to run with full permissions to the subdirectory that it's hosting. Doesn't have to run as root, but if it doesn't run as root, then whatever user it runs as has to have full permissions to that top level directory we call it the gateway root. There is no permissions mapping between users and POSIX permissions today. And so as long as the gateway has access to the files, then it can host those files. We do have bucket ACLs in place. And so the gateway itself would manage access to various buckets and objects based on the access control list. But the access control lists are defined with S3 semantics. And so this is how you would configure access on AWS S3. And so there's no settings to set POSIX ACLs on files and then get that translated up into the S3 layer. We do have the ability to set UID and GID on a file as they're being uploaded. So part of our account management in the IAM service is to have the user account have a UID and a GID set for that account. And there's options in the gateway such that when you upload those objects, they automatically get set to the right ownership for that user, group ownership and user ownership. And then we can, you can do management of that later on. We are looking into the ability to, since we know the user ID and the group ID of that IAM account, we can theoretically take a look at, are there POSIX ACLs or permissions bits to allow that access or disallow, but we're not necessarily sure if that's a right path forward, but we do have some investigations that we've done there. So we might be implementing that capability in the future.
Great. The next question from someone else is, what are the use cases for the S3 proxy?
Oh, yeah. So originally it was just for testing purposes only. It was very convenient for us to be able to see like performance differences between accessing an S3 target directly versus going through the gateway and then also to that same S3 target. So then we had a way to really see A/B comparisons of what is the gateway overhead in that case. And so that's where most of our performance articles in the wiki, and I think we published them in our blog post as well. Most of the performance analysis was done using this exact feature where we could say, I'm going to compare going directly to another S3 service versus going through the gateway to that S3 service. We have got some feedback from people that are interested in using the S3 proxy as a way to have their own user management though. So if you go directly to Amazon S3, for instance, you have to create Amazon users for everyone in your organization that needs to access those buckets and objects. If instead you prefer the model where you have sort of an organizational account that owns buckets and objects, but you want to give individual user access within your organization, if you want to cut that up and so you have more fine-grained control over who has access to what, you can use that S3 proxy to assign these users have access to these buckets and other users do not have access to those buckets. So you have that local control and all of those accounts are locally managed by you. So as users leave or as other things happen with those accounts, you still have full administrative access on the backend object store. So you can kind of think of it as like that organizational account is always there, full access to everything. You don't have to give up that kind of full access control for the primary S3 storage.
So another question from someone is asking again about IAM, and they're asking if they could take a config file from the current implementation and would it work with this new gateway, or how would that work exactly?
Right. No, these are not going to be compatible. We have different account structures with the new gateway, and so the this is probably very scriptable, so we'll probably be able to just dump the old account information and then have it like for each one of the accounts in there, we'll just have it do a create user API request into the new gateway. But yeah, no, not compatible accounting between them.
Yeah. I just wanted to say thank you, everyone, for all the questions that you've added to our chat. Please keep using the Q&A or the chat, or even if you are brave enough, you can raise your hand and I can unmute you to ask Ben any questions. I think the next one that I have is, what were some of like the biggest challenges you faced during the design and development, and how are they overcome?
Yeah, the main challenge for developing an S3 gateway is the complexity of the S3 API itself. And so that because of how extensive all of the parameters, every option for every action that's incoming to the S3 API, that means that we have to have a pretty big test matrix in order to test all of that functionality. And there's a pretty extensive API handler in the front end to be able to handle all the various requests incoming. So that's the biggest challenge. The just handling, implementing all the API handlers, that's not really a problem. We just, you have to sit down and just do the development. That's just time consuming more than anything else. So we have great developers over here. And so we were able to implement the majority of that S3 API. To the best of our knowledge, it's implementing all of the features that typical S3 clients would require. So things that were left out or are things like the billing, things that we wouldn't necessarily expect from the gateway access. The complexity is an interesting thing, and this isn't specific to us, right? So this is basically a community problem. So there's actually a SNIA storage developer conference is starting up a plug fest in order to start to standardize the test capabilities of various on-prem S3, like endpoints that are claim they implement the S3 protocol versus Amazon AWS S3, and see what level of compatibility is good enough, and see if we can formalize that a little bit more to say, if you do claim you have S3 compatibility, what exactly does that mean? How compatible is that? I can show the test matrix, but we do have a pretty extensive testing capability right now that is having to exercise all of the various parameters of all the various calls. Our testing strategy has really been to use the client commands that we have out in the community already. So we use the AWS CLI, since that's the officially supported CLI. And that one actually gives a lot of access to, like it has a high level S3 command interface where it's just the copy and make bucket and deletes and stuff. But then it also has an S3 API command subset where you can really target individual S3 APIs for more individual testing of each of those API sets. And then we also use the MinIO client. MC is a popular client, and then S3 command is also another Linux command that's popular out in the community. So we test all of these client commands in a large test matrix. Not all of them support all commands. The AWS CLI is the most complete of any of them, but what others offer, we do end up testing, and we have a test matrix in the wiki, and the testing documentation will show which ones support which various tests are capable and which ones are tested and passing, and if there's anything that's not working, it's all reported in that. For the most part, anything that's functional is working.
Would you like to show that GitHub wiki for anyone who might be more interested?
Yeah, I can. So back in the wiki, this is just under the integration tests. And so we have our test matrix. And so here's our symbols here. So testing and passing, testing and failing, not tested, partially tested, not applicable means that this command does not support that API. And then we have some that we've just noted ourselves like that needs a little bit more verification. And so you can see that the majority of the matrix is passing or not applicable, like if that command doesn't support that. So we have a lot of them that are filled out, but it is a pretty extensive API in here. Needs to be updated. We do have support for object lock now. It's just the test matrix hasn't been updated. And then these are the ones that are not expected to be used. And so we have a lot of the just the Amazon specific API calls. If there's anything in here that people need, we've just said, open a ticket and we can look at putting the API handlers in for that. But we don't envision anybody actually needing those for on-premise S3 access.
I'm seeing a really good suggestion from Evan that maybe we should change the color of the icons so for NA as check marks so they don't look so similar. That's a great idea, Evan. We will definitely do that.
Yeah. I think the idea was that it's meant to be green in the sense that it's either passing or not applicable. Like, so we were wanting to show kind of like all green there. We don't want it. I didn't want it to be red because I didn't want it to like look like it's a failing test when really it's just S3 command doesn't offer an abort multi-part upload or something. So we don't want to make it look like it's a failing test.
So you definitely went over this a little bit earlier, but do you want to expand a bit more about what are the newest features of the gateway and how they compare to the old gateway that we were using?
Sure, yeah. So I did mention this before. We've got several new features here. One that I saw in the Q&A and that I did go over was the object lock. So we just implemented the object lock retention capability there. So that's all in and functional now. We have also recently, well, not actually, these have been in for a little while, the logs and event notifications, and then more recently, the metrics. Let me go to the documentation again, because I've got this in the documentation just so that people can get familiar with where to find this, as everybody's going to forget this as soon as they get off the call. So so back in the wiki, we do have event notifications documented. These event notifications are in the same format that AWS event notifications are in. So it's the same structure and same fields that you can get there. The same schema is all defined by AWS. So we have some links to where to find that. For the notifications, we support today Kafka, Nats, and a webhook URL. And then we also allow filtering the events. And so you can specify in a filter, we have a way to generate a default filter config. And then it writes this event config.json file. And then you can modify this if you want to add or remove some of these notifications. So for instance, if you only care about object puts, you can specify just true for only object puts and let everything else be false, and then you only get those notifications. The event filter, you can only specify, so the biggest difference between event and logging between the gateway and AWS is that the admin is intended to be the consumer of these, not the bucket user. So on AWS, you would specify an event or logging, and then you would do that on a per bucket basis, and then you would get those events from that bucket sent to you. This is more intended to be consumed by site admins. And so this is globally configured. And so this is, if you enable event filters, it's just on for event notifications, it's on for all buckets. And you can only specify one event system right now. And so you would configure Kafka, Nats, or webhook for all of the buckets, and then that would send the notifications to your configured service. That does have bucket information in the notifications. So if you need to further split those messages out to other services, you could do that. So for instance, you could have Kafka consume these event notifications, and then you can send to other messaging queues based on what bucket is being sent. If you need individual users to consume just their bucket notifications, you could build up that service within these other systems here. The webhook is meant to just be kind of a general case for anybody that doesn't want to run their own messaging service. You can just have a webhook endpoint and it just sends these JSON encoded events directly to that web endpoint, the HTTP endpoint there. Looks like we don't have an example of what those look like here. The logging, we do have examples in this. And so the logging is also globally set. So this would be logging for all buckets, but it is using the same log format that AWS S3 uses, which is defined in their user guide. Here's an example output that you would see from that system, but this is generated from the gateway here. There's lots of information in these, but this is more like access. This is just access logs, or you can think of it as like audit logging too. So it just logs all the actions to the buckets. Let's see, so for this one, we also support just the log file itself that's local on the system from where the gateway is running, or also webhooks. We give a little example of how to do a test webhook if you want to play around with that. But the ones that are sent to the webhooks will be JSON encoded, whereas the ones through the log file are just going to be a log file that matches the AWS formatting. Then the metrics is the most recent one. And so we support statsd and Datadog now. Here's some configuration options for the metrics. So we are setting these following keys for basically failed and success, bytes written, objects created, bytes read, objects removed. So you can just keep stats of like how much data is flowing through the gateway. And we tag all of these with the service by default is going to be as the host name of the gateway, so that you can see which gateway is contributing to the throughput of the system, or you can turn off. You can select all services and see the overall throughput of the system. The action is going to be the API request, the actual S3 API that's being called in that case. The high-level HTTP methods, so put, get, post, or delete, and then the API, which is going to be S3 for all of these. But as we expand, we might have things like admin for our admin API if we need to start doing some stats on the admin requests. And so we give some examples of how to send this to Prometheus, InfluxDB, Datadog. So these are kind of the basic, that are the general case metrics services that we would expect to be running at various sites here. Did I cover all of the?
Yeah, you did.
Okay.
We have a question from Jens. So when he's not enabling Glacier Mode, but uses ScoutAM as the backend, what happens when someone tries to access an offline file? I think you showed this in the Glacier demo, but just to reiterate.
Yes, yeah, no, that's great. So perfect question. So when we're not using Glacier Mode, so if you have the Glacier disabled and you access an offline file, then it's going to block on the read. And so this is just a standard demand stage request. And so in ScoutFS, if you just start reading an offline file, it blocks on that read system call and then waits for ScoutAM to repopulate that file data from the archive. But it is blocking. And so it's similarly with the gateway, that's a blocking read on that file. And so the client has to just wait for that get to complete. And so the difficulty there is adjusting the timeout values in the client, because it's the client that decides how long is it going to wait for that request to happen. And if you're dealing with tapes, it could be minutes or hours or something later that request actually gets serviced. And so you have to have appropriate timeout values at the client to be able to deal with kind of the longer latency for that initial data access on the back end. But yeah, it should work just fine as long as the timeouts are capable of the realistic recall timeframes.
Our next question is from Tim. And so does the logging support multi-object delete yet?
Yeah, so that would be, we did this in the event notifications. So yes, the event notifications, when you do delete objects, there's a notification per object that's deleted in there. And so you get many event notifications per file in that request there.
So next, there was a question earlier about the compatibility for config files. So I know our VP of Operations, Nathan's on this call. If he wants to talk about the process to describe the process for Versity customers to upgrade from the current gateway to the Versity S3 Gateway, and expand on that a bit more.
Yeah, this is Nate. Just want to make sure you can hear me all right?
Yep, we can hear you fine.
Okay, great. Yep. So the config files are different, but they're similar enough that we will be able to assist you in converting those configurations over. The upgrade process will really just be essentially, converting your configuration files from the Scout Gateway format to the Versity Gateway format, and then doing a yum remove and then a yum install of the new Versity Gateway package, and then starting up the services. So I anticipate this to be a very straightforward conversion and upgrade for the majority of customers. But we're those customers that have Slack channels, you can reach out to us there, or you can open up tickets and we can assist with that conversion.
Great,
that might be a
thank you.
good segue into the how do you request help, right? Where do you go for support stuff? And so our customers are going to continue to use their standard support paths, but this is a community project. So we do have issue tracking in the GitHub projects, GitHub issues, as well as the discussions board is enabled for just general conversational questions. So we expect the community to come in through those mechanisms directly in GitHub. Customers are welcome to use that, but we can also accept the standard support paths, and we'll be opening up issues on your behalf if required within GitHub. So customers don't need to access GitHub ever, but it's there if they're interested in seeing what the community interfaces look like.
And just to add, there are options for enterprise support if you're not an existing ScoutAM customer but want to use the gateway for something else. There are options for that.
Yeah, I think my last question for you, Ben, is very existential. What do you see as your vision for the future of the Versity S3 Gateway?
Yeah, so I think that this platform opens up a lot of opportunities for new backend capability. And so, we can step back and think about that sure, you can add any storage backend that you want. We have existing other storage platforms that might need to add S3 capability. In fact, we've seen in the news some of the people that were using MinIO before and kind of got flamed for maybe some license infringement there. So we're happy to help onboard those partners into the platform to enable S3 access into their platform for existing storage systems. But the capability is there to be able to develop new storage systems as well based on that S3 gateway. And so it doesn't have to be existing storage platforms. If somebody is interested in maybe a new way of implementing the on-disk formats of an object storage system, they don't have to start from scratch. You could start with the gateway, use all of the API handlers, all of the S3 processing, which is quite a bit. All that difficulty is already solved in the gateway, and then you can start implementing any new storage backend that you want in there. And so I'd really like to see this as kind of the de facto community standard for any on-prem or hosted, self-hosted S3 access, and really see that kind of develop over time, all the backend capabilities of various projects that people would like to start incorporating that.
Matthew has a question. I think just to clarify for anyone on the call, is support for enterprise support tied into on top of ScoutAM or tied into our ScoutAM contract?
That's a great question. I apologize if it wasn't clear, and thanks for asking for the clarification. If you are a ScoutAM customer, you are already supported on the Versity Gateway. You don't need to do anything separate. It's already part of your subscription. If you were using the Versity Gateway and you were not already a ScoutAM customer, then you could look at buying enterprise support. And there is best effort support in the community with the GitHub tickets. So 3 different options there.
Does anyone else have any other questions? Otherwise, I'll hand it over to Megan to give a brief product roadmap. But this webinar is for you guys. So if you have any questions, please raise your hand, ask in the chat.
I don't see any questions, so maybe we can look at the roadmap while people think about it. So just in terms of what we're doing with the gateway and the roadmap, it's heavily influenced by customer requests and partner requests. We've seen a lot of interest, as Ben said earlier in the meeting, a lot of interest from the community, from people who are interested in using it, and that's definitely heavily influencing the roadmap. So current functionality, Ben already talked about a lot of these items that the gateway currently does, but since it was our 1.0 release, I wanted to make sure and list everything that it already does there on the left. And then our current focus is expanding our test suite using the common applications that people would use to do the different operations. And then we're always working on performance optimizations and supporting additional backends. Azure is one that really has our attention right now, making sure that that backend works and that you can store data S3 you can put or get to Azure. And then the ScoutAM integration, I want to take a minute and talk about this one. You can use the gateway with ScoutAM and it works, and Ben demoed it for us earlier in the meeting. What this roadmap item is a more integrated installation and configuration approach that we're looking at. You know, can we make it more integrated and more, for instance, is there something that we could do to have like a click a button install from the UI or something like that? We're just looking at what are ways to make it easier and more integrated and just a smoother experience. Right now, it's a very good experience. It's 2 separate RPMs. You have config files, and that's really great, but we just want to see if we can make it a little bit better for our customers. And then in terms of the future, again, heavily dependent on what partners are asking for, but we seem to get additional requests for IAM service integrations. We have a potential partner now who's looking very closely at POSIX operations. They have an S3 to POSIX use case that they wanted a couple of specific things. So we're looking at the select object content versioning for that. And then additional backends as we get the request. We have one of our customers who's really interested in SOS API, so we're working on getting the specs for that and seeing if we can get that going in the gateway as well. So that's it for the current roadmap. If there's something that you're interested in that you don't see on there, definitely talk to us or ask a question. We're happy to discuss anything you might need with the gateway.
So I had a question just to reiterate for people, you know, it's our version 1 release today. It's generally available. People can use it in production environments. Just so people are clear, what are all the resources that are available for the Versity Gateway user community as they're trying to install it in their systems?
Yeah, so the best place to start is the GitHub documentation in the wiki. There's fairly complete documentation that we're including a quick start for just helping getting going there. You can ask questions in the discussion, the GitHub discussions, or open up any issues there. And our customers, just the standard support channels that make use of all of the standard support interfaces that you have with your service already.
So once again, I just want to thank everyone for coming to this session despite our technical difficulties in the beginning. I'm very grateful for all of you to have stayed to the end. We'll be sending a copy of the slides and a recording to this session for everyone who subscribed to our newsletter or registered. We'll also be sending a survey out about the webinar. So if you have some time later, please, we'd really appreciate if you could fill that out for us. Thank you again for taking time out of your very busy day to attend, and I hope you have a great day, and I'll give you back your time. Have a great day, everyone. Thank you.